So this is the first numerical, and in this numerical we are required to find the load resistance and maximum power transferred using maximum power transfer theorem. So first of all, we will calculate the thevenin resistance, and the method of calculating the thevenin resistance has already been mentioned many times. So again, it is depicted here. So we will remove the load to make it open circuit, and then we will calculate the Thevenin resistance by using the current flow back into the circuit. Okay, so this 50 ohm resistance will be short circuited, and 30 ohms and 20 ohms will be in parallel. Okay, so 30 ohm and 20 ohm is in parallel, and when they are connected with the series combination of 38 ohms, we get the Thevenin resistance as 50 ohms. Okay, so for the maximum power transfer according to our theorem, the maximum power will be transferred if and only if the load resistance is equal to Thevenin resistance. So we were required to find out the load resistance, so it is equal to 50 ohms, as it is the value of Thevenin resistance. Okay, so next is to calculate the maximum power. So to calculate the maximum power, we are required to calculate the open circuit voltage or the Thevenin voltage. So the maximum power transfer can be calculated depending upon our it is a choice. You can say it is, we are having a choice that which method is to be followed. So here, first of all, we will calculate, since we have begun with Thevenin theorem. So in the first circuit, first loop, the loop is also shown when the load is open circuit. So the resistance is 50 ohms and the voltage is also 50 volts. So the current flowing through the circuit will be 1 ampere. Okay, so we are talking about this circuit. So the load resistance is open, so the current flowing will be 1 ampere. Okay, so when the current flowing is 1 ampere, then this parallel branch will also experience the current of 1 ampere. So this 20 into 1, so it becomes, open circuit voltage becomes 20 volts. So when the voltage is known to us, load resistance is known to us, we can calculate the maximum power which will be transferred by using this formula, that is square of the open circuit voltage upon 4 times the load resistance, which comes out to be 2 watt. Okay, is this clear to everyone? Rahul, is this clear?
Yes, sir.
सर करंट निकालने के बाद सर क्या किया था सर 1 एम्पीयर करंट निकालने के बाद
After calculating the 1 ampere current, we calculated the open circuit voltage. Okay, because we were required to calculate the open circuit voltage because it was the need according to our formula. Okay, so the open circuit voltage which will be across this load will be same as its parallel combination. So the drop across the 20 ohms was calculated and it was treated as the open circuit voltage. Okay, so 20 into 1, so this is, it comes out to be 20 volts. Okay, is this clear? Is this clear
Yes,
to
sir.
everyone?
Yes.
Okay. So if we calculate the current in this first loop for this numerical, so 100 volts is the voltage and 20 ohm is our resistance. So current comes out to be 5 amperes, and this 10 into 5, it is a 50 volts, which is the drop or the voltage which is appearing across this parallel branch. Okay, so same will be the open circuit voltage or Thevenin voltage. So the power transfer will be maximum when RT is equal to RL. Okay. Okay, so consider one more numerical based on this. So find the RT and RL and maximum power transfer for this circuit. So this numerical comprises of current source and voltage source. Okay. So when this situation occurs, sometimes it is difficult to calculate, and to make things easy, what we do that we calculate the current source into voltage source. Okay, so what will be the polarity of this 3 ohm resistance if we replace this by a voltage source? What will be its polarity? We will apply this formula for the maximum power transfer to get the result. Okay,